This is Tech Math 2. And we're going to do sections 1.4 and 1.5 today. And the first thing we're going to do is talk about measurement. So we have something that's accuracy. And we have something else that is called precision. And precision, oh yeah, precision's on the next page. And because we're not an English class, there's not going to be a multiple choice thing that tells you, or an essay question that's going to want you to know the difference between those two. But there is a difference between accuracy and precision. So I got a 2x4 and I'm cutting it with a chainsaw and I'm cutting it at 2 feet in. Then I'm pretty accurate where I'm cutting it. But my precision's off a little bit because the chainsaw is wide, right? Whereas I take a smaller saw and I can cut, and I still get the same amount of accuracy, but my precision's better than I had before. So that's a chainsaw saw example. Just like, I knew you wanted to have that one. So anyway, accuracy has to do with significant digits. So when I take 1 and I divide it by 3 and my calculator says it's 0.3333333, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is that really what it means? It probably doesn't. Probably really doesn't mean that, because it depends on what I cut it with. So if I was using the best lathe I have, then I can get down to 10,000ths easily. So I can get down to there. But these guys, I really can't tell you that I'm that accurate. Okay, so I'm limited in the amount of significant digits I have. When I go and I multiply 2 times 8, I get 16. But the 2 only has 1 significant digit, and the 8 only has 1 significant digit. A better answer would be 20. A better answer would be 20? Yeah. So if I want 16, I should have said 2.0 times 8.0. Now I have 2 significant digits, and now I can have 20. Oh, 16. Oh, well, I wrote down the right answer. I said the wrong one. So when it comes to problems that deal with measurement, I have to think about the significant digits I have. When I have 2 apples and I have 8 apples, am I dealing with measurements? I have 8 apples and I have 2 bags, each with 8 apples.
Well, why would it be 20 without 0.0?
Then in this case, I have 16 apples because I'm not dealing with measurement. I'm not dealing with bringing out a tape measure and putting it on. I'm not dealing with its 1 astronomical unit to the sun. Okay, I counted the apples in the bag as 8. I counted the bags as 2. I have 16 apples. See the difference? No, you don't. Do you see that?
You're just talking like rounding?
Yeah, basically. So, yeah. So if I have a field that's 144 feet by 287 feet, how many square feet do I have? I take out my calculator. 144 times 287, and I get 41328 feet squared. And then I say, well, I really don't know that because I don't know that this is 144.00 feet. I didn't measure it that close. I don't know that this is 287.00 feet. If I knew that, if I had precision equipment and I knew it that close, then I can keep the 5 significant digits that I have there and I'd be okay. But I don't. I only have 3 significant digits there if that's a 3, and I only have 3 over here. So my final answer can only have 3 in it. 41300 feet. That's as good as I know my answer to. It doesn't matter that my calculator gave me 5 or 10 digits. I can't measure it any closer than that. I can't tell you it's any closer than that because in the original measurement, I didn't measure it to be that close. Okay? Yeah.
How is 0 significant in the factor but not in the product?
Okay. So now we're on page 15 of your book. And on 15 of the book, it has rules for significant digits. And the first rule says, all non-zero digits are significant. Okay, so all non-zero digits are significant. All right, so I got 1, 2, 3. I have 3 significant digits. I got 1, 2, 3, 4. I have 4 significant digits. I have 1, 2.345. I have 5 significant digits. Rule 2. All zeros between significant digits are significant. All right, so all zeros between significant digits are significant. So I got 1, 0, 2, 3. I have 4 significant digits. I've got 1, 0, 2, 0, 3. I have 5 significant digits. All right. Rule number 3. Does that answer any of your questions yet? Okay. Rule number 3 says a 0 in a number greater than 1, which is specially tagged, is significant. All right, so I got a tagged 0. Yeah, there we go. Tagged 0. I could spell 0.
Z.
With a Z, really? Is significant. So I got 1, 0, 0, 1, 2, 0, 0, 1. No, I don't have that. 0, 0, 0. Okay? And I put a bar above that 0. Then I've got 1, 2, 3, 4, 5, 6 significant digits. I've got 1, 2, 3, 0, 0, 0, 0. And I put a bar there. I've got 1, 2, 3, 4, 5 significant digits. Because the guy with the bar is significant, the 0 in between 2 significant digits is significant. So that goes back to rule 2. All right. Rule number 4. All zeros to the right of a significant digit in a decimal point are significant. All zeros to the right of a significant digit and a decimal point. So if I have, okay, so all zeros to the right of a significant digit, and notice that and, that means it has to both be true, a decimal point, are significant. So if I have 1, 2, 0, 0, 0, then I have 2 significant digits. But if I have 1, 2.000, I have 5 significant digits. So there was no point in here. So that means that my significant digits end right there. there is a point here, so here's our zeros to the right of a significant digit to support this program anymore. So they're not going to fix that for me. All right, so rule number 5. Number 5. Zeros to the right of a whole number that are not tagged are not significant. So 2, 3, 0, 0, I have 2 significant digits. 1, 0, 1, 0, 0, 0, 0, 0, 0. I have 3 significant digits. All right? Zeros to the left are not significant. Number 6, zeros left of a significant digit, not significant. Now, why would you write 0, 0, 0, 0, 1, 2, 3? I don't know why you'd do that, but if you did, you'd only have 3 significant digits doing it. I mean, that's misspelled, right? I wish you just marked it as being misspelled. Okay. Also, if I had 0.0000123, I also only have 3 significant digits. Because none of these zeros were significant, even though I have a decimal point there, it doesn't matter. You know, so 1.000123, I have 7 significant digits. Okay, good enough? Now, when do significant digits factor into your grade on a test? That's what you're really wondering about, right? Yeah, how about, yeah.
Question. This might be a stupid question.
Oh, I hope so.
The small meters, METRES, is that like different than METERS? Or
I doubt it. Oh, tenths of meters. That's interesting that they spelled it that way. We were at one time using an English spelling book, an English math book, and they had all kinds of weird spellings in it. But no, I would call that a misprint. The E and the R turned around. This is only a 2nd edition book. You know, wait for the 3rd edition; they might get it spelled right. Yeah, exactly. Yeah. The other issue is there are significant errors in the answer key in the back of the book too. Some graduate student did that, and no one bothered to look, and that's kind of funny too. Okay. Any other questions? No, there's nothing stupid about the author's inability to do anything. Okay, so the issue is precision and accuracy. That's the issue. So we have some number, and we want to know the accuracy, which means the significant digits, and we want to know the precision, if I could spell precision. So I've got 1,352 feet. So my accuracy is, I have 4 significant digits. My precision is to 1 foot. So I can't say that I know this answer to a half foot or to an inch. I don't. 135.2 feet. Okay, number of significant digits, 4 significant digits, but my precision has now changed, and I know it to, what do I know it to? I don't know. 2/10 of a foot. No, 1/10 of a foot is what I know it to. Because it's not 0.3 and it's not 0.1, it's 0.2. So I know it to 1/10 of a foot, which would be 1.2 inches. But you probably like the 0.1 foot better, right? That makes more sense. Yeah, that's what delayed me in coming up with that answer, because I was trying to multiply 0.1 times 12. That delayed the process. All right. 1,000,000 grams. I have 1 significant digit, and my precision is 100 kilograms. I know it's not 20000, and I know it's not 99999. Okay, or 9000 grams. So my precision is 100 kilograms. Okay, good enough? One more? No? One more? There's enough in the book? Okay. So we'll work the 3 homework problems from the section. How disgusting. Number 12. Oh, good. At least it's an ohm problem, right? 205,000 ohms. And we want to know the accuracy. So I have 3 significant digits. So I know the accuracy. And that's the only thing I want to know? Well, I guess that's enough then. My precision is, they didn't ask me for the precision, but my precision is 1 kilo ohm, right? 1,000 ohms. It's not 204 and it's not 206. So my precision is
that KR?
K ohm, as in omega, as in the last digit of the Greek alphabet. Yeah. All right. And don't worry about it. Ohm will be a normal word for you very shortly. Won't it? Yeah, pretty much. Yeah, pretty much. You ohm. Anyway. Same thing. Precision, 0.050 kilometers. Okay, so that's my question. I want to know the precision, and the precision is going to be 1 meter. It's not 0.051 and it's not 0.049. The precision will be 1 meter. How many significant digits? I have 2 significant digits. The problem didn't ask that, but we're just going to throw that in anyway. Number 38. In this measurement set of measurements, find the measurement that is least accurate and the one that's least precise. Least accurate and least precise. This is probably a trick question, right? 39, 38. Sure, I'm glad I'm not doing 39. Okay, so 38, I got 284.0 miles, 6.35 miles, 7.000 miles, and 0.05 miles. It would be cool if I was consistent abbreviating miles the same way, right? So the first thing we're going to look for is significant digits. I got 4, 3, 4, 2. So the guy that's least accurate would be the 2 guy. Least accurate. All right, and then we're looking for precision. So here we have 1/10 of a mile. Here we have 100th of a mile. Here we have 1,000th of a mile. And here we have 100th of a mile. So the least precise, that guy. However you spell precise. Okay, good enough? Now, we turn to apples and oranges, section 1.5. So I've got 4 apples and I'm adding 3 oranges. What do I have left over? What is this Q doing here? That's not an orange. Orange. Okay, there we go. What do we got? Da, 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 da. No? What? Take your calculator out. Find out what you got. No? Right, you can't add apples and oranges. You only can add the same thing, right? So when I get done, I have 4 apples and I've got 3 oranges, and there's nothing I can do about it. All right. So if I've got 5 inches and 2 feet, and I add it together, what do I get?
2.5.
You know? Well, the problem is I gotta be in either inches or be in feet, right? So I've got 5 inches plus 24 inches, and I can have 29 inches. I can do that. Or I can say I got 2 feet and I got 5/12 of a foot, and now I've got 2 and 5/12 of a foot. Okay, so I can't add things if I have different units. Can I multiply things if I have different units? Yeah, of course. I can have voltage is current times resistance. So I can have 5 amps, and I can have 400 ohms, and I can have a voltage that's 1600 volts. So that's perfectly, I can multiply things with different units, but I can't add and I can't subtract things with different units. Now, why did we do that to ourselves anyway? Why didn't we just make it easy? Well, it has to do with the 30-year war and the 100-year war is what it has to do with. So after we had a 30-year war and a 100-year war, the French and the English didn't like each other very much. So you have London sitting here, the seat of all learning, all knowledgeable about everything, and then you have Paris sitting over here. Paris, P-I-R-I-S, P-A-R-I-S. And Paris sitting over here, the seat of all knowledge and of everything. And they're looking at each other and says, feet and meters. And they look over here and say, Fahrenheit, Celsius. And they sit over here and they say, Rankine, Kelvin. So they're sitting there on purpose, hosing each other over, making our lives miserable. Okay, it's all their fault. Now, the same thing, when I was teaching the Nicaraguans, the same thing had happened. The Spanish language is such that the Spaniards in Spain don't want to use English words. Okay, their language is pure. So they have a word for amps and a word for ohms, resistance, that are Spanish words that are not English. Okay? In the New World, if you're in Central America and you pick up the phone and talk to a technician, what language is he speaking? English, right. So the Nicaraguan engineers told me, don't teach the Spanish words in your electronics class. They're never going to hear them. The only place anybody hears those words is in Spain and in Mexico City at the university. That's the only place they're used. Every place else, Central America, South America, uses English words when you're talking about technology. Okay, fine. So I go to the telephone company, and there's a really sweet lady there in her 40s in charge of the telephone system. The telephone system was just bought out by the Spaniards, so she's from Spain. And, oh yeah, you're going to teach all the Spanish words. We didn't. And I guess one of those things. All right, so make certain, page 17, make certain all your measurements are expressed in the same unit before you add subtract. Then you have to still round off the result due to precision and preciseness. You still have to do that. On page 18, you're multiplying and dividing. You can multiply and divide anything you want. You still have to round off the significant digits that you need. All right. Other ones, you only get them once. But, all right, so there you go. Now we're back to these problems. The dean's office is right over there. But so if something's wrong, huh? Yeah. Oh, we got a math question.
No.
No, no math question?
No.
Now, we have a little problem. The issue is, the video is still being made. But I can edit it out.
I think you should leave it.
Uh,
It gives it character.
There is 99 weeks of unemployment out there that I could get, right? Yeah, you got a point there. Okay, so where were
Good
we?
point, good point.
Yeah, back to number 6. So now everybody's going to have to listen to the video when I get it made to see what I did. Number 6. All right, it looks like I got 7.639 miles. And I've got 14.48 miles. And I've got 1.0004 miles. And I've got 0.68 miles. All right, so I'm just going to add that. I get a 4. I get a 9. Get another 9. I get a 7. I get a 3. I get a 2 miles. Okay, so I added everything together. Now, how many significant digits do I have? We'll ask that first. Significant digits, 4, 4, 4, 2. Okay. What is my precision?
It's only, there's 1.004, not 0004.
Well, it does, I don't have to solve the problem in the book. Only you do. No, really. I mean, seriously. I don't have to solve the problem in the book. Okay, we'll solve it your way. All right. That means I got to go and rewrite all these numbers here. Okay, so what's the answer if I do that? You don't know yet? Okay. 4, 3, 1 to carry, 9, 1 to carry, 7, 1 to carry, 3, 2. Okay, is that better? Better about that? Precision. 1,
You gotta change the 4 under significant digits to 3.
no, 1, 2, 3, 4.
Oh, you already changed.
It should have been 5.
Never mind.
It should have complained that it wasn't
Okay.
5, yeah. I saw 1 1,000th, 1 100th, 1 1,000th, 1 100th. All right, so no matter what, I'm no more precise than 1 100th, and I shouldn't keep any more than that. And I have 2 significant digits, but those 2 significant digits are part of that hundredths thing, right? So I'm going to say the answer is 3.79 miles. Now, does that follow our rules? Okay, so our rules say, make certain that all measurements are equally, then round to the results to the same precision as the least precise measurement. Same precision as the least precise measurement. So that's what I did. So that's perfectly okay. All right. Follow my own rules. Number 19 with only 9 minutes to go. Number 19. 4 pieces of metal. 0.149 inches. 0.407 inches. 1.028 inches. 0.77 inches are to be bolted together. What is the total thickness of the 4 pieces? And the right answer is, I don't know. There's no way I can tell. If I go and drill a hole through those 4 pieces and put a bolt in it and tighten up that bolt, I'm not going to get the addition of these guys, right? There's going to be spacing in between them. I may tighten the bolt a whole lot and squeeze them closer together. Okay, but we'll forget all those things and just do the problem, right? Okay, do the stupid problem, done. Okay, what do we got here? 9 and 10. So that's a 4, 2 to carry. And this is a 8 and a 7, so that's 5, 1 to carry. And so that's a 3, 1 to carry, 2 inches. But we have to round to the least precise, so our answer is going to be 5.35 inches. But until I measure it, I really can't tell, because any metal filings caused by me doing the drilling can cause things to go wrong. But this is only chapter 1, so we don't have to overthink the problem too far. Number 26. Gee, why don't we do 21? That looks cool. Resistance problem. Number 26. Stay on task. 8.2 kilometers times 6.75 kilometers. Okay, time to use the calculator. 8.2 times 6.75 equals. So we got 5.35 kilometers squared is what I have. That's not my final answer though, because it says when multiply and dividing, multiply and divide, round the results to the same number of significant digits as the measurement with the least number of significant digits. Okay, this guy's got the least number, he has 2. So I got to round this guy to 255 kilometers squared. Back to the issue of when will significant digits affect your grade. Okay, we forgot to answer that question, right? So let's say, well, first of all, one of the Corderville grading rules is that if you get 100 on a test, you get everything right on a test, then on the next test you also get 100. You have to take the test, you get a 73, but 100 goes in the grade book. Okay. So, in the event that you don't have anything else wrong on your test and you miss a significant digit, then that's minus 0.1 for significant digits. If you've already missed 3 or 4 points, then I don't take off for significant digits. So the only time that will come into a grading effect on you is as your yeah, it happened 15 years ago. A female got 100 on one of my tests. Yeah, it happened. So it can happen. Yeah. Yeah.
What are they doing with that?
That's the sign language people, so they're talking with their hands.
Sounds like it.
I can take them to somebody that does it for real.
Yeah, well, you have to practice somehow. They're all excited over there. It's really is a cool thing. Number 36. So anyway, back to the last guy we did. You have an answer, but then you have to round it off, and you call that your final answer. You'd circle it, you'd square it, and you'd make it clear that that's your final answer somehow. And a lot of our tests are multiple choice, so it wouldn't matter anyway, but you put down an A, B, or C. Back to trying to do the last problem in the problem set. 36. Oh, come on. You got to be kidding me. Okay. So I got 190 grams divided by 3.4 centimeters. 1.6 centimeters. 8.4 centimeters. All right, well, we just throw this in our calculator. 190 divided by 3.4 divided by 1.6 divided by 8.4, and so I got 4.157913165 is what my calculator is telling me. Okay, the least number of significant digits I have is 3. 2 is 2. 3, 2. So that means I can only have 2 in my answer. So is this 1 is this 4.2 or is this 4.1?
4.2.
So in general, your 8th grade math teacher told you that if you have a 5 and you're odd, you round up. If this were 4.25, you would keep it as 4.2. You remember that? Your 8th grade math teacher teaching you that? Or was it 6th grade? I forget which.
I always rounded up.
You always round up.
Five.
Okay, so now I have 2 minutes to show you that rounding up all the time is not a good idea. Okay, and it's okay to round up all the time. I'm going to mark both of those right, by the way.
What unit measure? What unit measure would that be? I don't understand.
Oh, the unit.
Grams by weight.
Yeah. All right, back to the unit. So we didn't put the units in. Okay, so I'm calling the right answer 4.2 grams per centimeter cubed. Is exactly what you're right. Because there's also the minus 0.1 units grade if you left the units off. Yeah. All right, back to the explanation. If I had 1.5 and 2.5 and 3.5 and 4.5, and I add those up together, I'd have 4, 8, 10, 11, 12, right? I'd have 12. If I decided that I'm going to round them off before I add, and that becomes a 2, 3, 4, 5, and I add those together, I now get 14. If I decide that I'm going to round my way and say this is a 2, that's a 2, this is a 4, this is a 4, I get 12. So, because if you always round at 5, if you always round up, you're going to introduce an error that you wouldn't have if you rounded up even, not up. Round up when it's odd and not round up when it's even.
That pertains to circles, right? Because of.
Well, that only counts when you're adding. So it's only an adding subtracting thing, really. So my 8th grade math teacher taught me the rounding rules that I'm talking to you about. But if you were taught different rounding rules, use them. So if you were taught at your high school or your in 6th grade, always round up when you have a 5, go ahead and do it because I'm going to count it right. Okay. Now what are we doing for class tomorrow?
Nothing, there you are.
Sleeping in because I'm going to be at Millard's house. Exactly. Okay. And this ends chapter 1, section 1.4 and 1 part 5.